Today we're going to talk about ionic bonding. All right. Now, ionic bonding, it occurs between a metal and a non-metal. Okay. So remember, all of your metals are on the left side of the staircase, and all of your non-metals are over here on the right side. Okay. So the reason that ionic bonding occurs is because of electronegativities. Our electronegativity values between metals and nonmetals have a substantial difference. Okay, so with covalent bonding, we talked about how those values are really, really close together. So neither atom is strong enough to take the other's electrons. But with ionic bonding, the nonmetals are always going to have a higher electronegativity value, and they're always going to be able to steal electrons from those metals. Okay. Now, when that occurs, one element or one atom will gain electrons. Okay, from the other. In order to become stable. And so every atom always wants to have that stable octet in the outer shell. Okay, and when you gain or lose electrons, we create charged atoms called ions, hence ionic bonding. All right, so let's look at sodium. All right, sodium is number 11, okay, and sodium is in the third period, so that means it has 3 shells. It has 3 layers, okay. It has 11 electrons. That first layer can hold 2 electrons. The second layer can hold 8 electrons. And that third layer holds that 11th and final electron, okay. Now, we say that the alkali metals have 1 valence electron. Well, that's because in our outer shell here, there is only 1 electron. So all of the alkali metals have that 1 valence outer shell electron. Now, the question I always pose is, in order for sodium to be stable, it wants 8. So it's either going to gain 7 or lose 1. And the easier thing to do would be for it just to lose that 1 electron in the outer shell. So that 1 electron just kind of goes away. Well, when that happens, not only the electron is gone, but the whole shell is gone. It's missing. So now as we look at our outer shell, sodium has 8 electrons. So it's stable. But that changes what our charge is. It's no longer neutral. Remember, sodium is 11, so that means it has 11 protons. Well, we took an electron away, so that means it now has 10 electrons. So I have 11 positives and 10 negatives, giving me an overall charge of positive 1. So this sodium is going to be positive. Okay? Well, now let's look on the other side of the periodic table at chlorine. Chlorine is also in the third period. It also has 3 layers. Okay. That first layer has 2. The second layer has 8. And that third and final layer has a total of 7, giving it a grand total of 17. Well, it doesn't have 8. There is a space right here that is missing. It's missing an electron. So, in order for it to be stable, chlorine's either going to gain 1 electron or it's going to lose all 7. Well, the easier thing to do is for it to gain 1. So, it's going to pull an electron into its outermost layer, giving it now 8. So, chlorine, has 17 protons. And it now has 18 electrons, giving it an overall charge of -1. 17 minus 18 would give us -1. So this chlorine has a negative charge. Well, let's look at them in more simplistic terms. If I'm just looking at sodium with my valence shell, so for ionic bonding, we don't have to worry about all those inner layers. We just worry about the outer layers. All right, and chlorine has 7 valence electrons in its outermost layer. Well, remember, one's going to lose, one's going to gain, and it's much easier for chlorine to gain that 1 than sodium to pull all those other 7 away from chlorine. So chlorine is negative, sodium is now positive, and just like magnets, a north and a south pole, opposites attract. I've got a positive sodium and a negative chlorine, and they stick together just like magnets, and that is an ionic bond. So my formula is NaCl. You always write your positive cation first, okay? But sodium chloride, table salt, there you go. All right, let's look at another example. Let's look at calcium plus oxygen. Calcium is in the second column. It's an alkaline earth. Calcium has 2 valence electrons. Oxygen has 6 valence electrons. Well, oxygen wants 8, so the easiest thing to do is for oxygen just to steal calcium's electron, giving it a -2 charge. That means calcium lost its 2 electrons, giving it a +2 charge. And we are left with a formula of CaO, calcium oxide. All right, let's do one a little bit harder. Let's do magnesium plus fluorine. Magnesium, second column again, alkaline earth, and it's got 2 valence electrons. Fluorine, a halogen, has 7 valence electrons. Fluorine needs 8. It's going to steal that and give it a -1 charge. But I've got a problem. I've got 1 left over. Well, all we need to do is just add more fluorine. So fluorine, another fluorine atom comes along. It's got 7. It's going to steal that one. Another -1 charge. And I'm left with a magnesium that's lost 2 electrons, so it's a +2 charge. Now count up what you got. I've got a magnesium, my positive, and I've got 2 fluorines, MgF2. So all you need to make sure that you know is you know your valence electrons, know your cations and your anions, who's going to lose, who's going to gain, and if you need to add an element, then just add one of your atoms, okay? Otherwise, that's about it. Next class, we're going to talk about the shape of molecules and how we get those. Until then, remember, work together, help each other, and make the world a better place. See ya.